Welcome back, everyone. Today we are going to go through the long requested August 2023 Earth Science Regents. So I'm going to go do the whole thing again, so you can follow along however you want. Maybe do it first and then watch the video, or pause it and do the questions along with me and then wait for my explanation, whatever you want to do. Alright, here we go. The whole thing, starting on question 1. Here we go. Question 1. Which two factors cause Earth and the other planets to become layered during the formation of our solar system? So keyword here is going to be layered, and whenever you see the word layered, you're going to think density. And it says, which two factors cause the Earth and other planets to become layered in the solar system? So things that create, what's going to create the planet is going to be gravity, because now there's two options here that say density, so you got to be careful. The distance from the moon has absolutely nothing to do with the fact that planets are being layered. So 1 is going to be your answer on that one. Number 2, a photograph shows an object labeled an A that was observed in the night sky for several weeks. That's all we see. What's the celestial object labeled A? Okay, there's a tail. By the way, I just want to say I'm doing this off the cusp. I did not do this, so this is my thought process of talking out loud of how I would figure these out. So something with a tail is going to be a comet. 4. Alright, number 3. The latitudes of the Tropic of Cancer and Tropic of Capricorn are determined by what? Alright, so latitude is going to be 23.5 degrees north for Tropic of Cancer and 23.5 degrees south. So that's going to be corresponding with the tilt of the Earth. The Earth is tilted about 23.5 degrees on its side, right there. The Coriolis effect can be best used to explain what? Coriolis effect is due to the Earth's rotation. That's something you have to remember. So you're looking for something like spinning or rotation. And then it also causes two things. So this one is what it causes. So it's going to cause the ocean currents to change directions and the wind. So those are like the three things there. So deflection of the wind is the best answer. What is the approximate rate of revolution? Revolution is how long it takes to go around the sun. So that's 365 days. And it's 360 degrees. So that means it's about 1 degree per day. Okay, star trails. That thing in the middle is Polaris. Star trails are to do with the Earth's rotation. The star at the center of the image did not leave the trail because it is what? It's directly over the Earth's axis. That's Polaris. It doesn't move. Which table best lists the difference between a terrestrial and Jovian planet? Okay, the terrestrial are the rocky planets, and the Jovians are the gas. Gas giants are large. Terrestrial are pretty small. So we just got to find that. Terrestrial, rocky and small, gaseous and large. 1. Alright, we got moon phases. Which diagram best represents the moon on June 3rd? So there's like a little pattern here. New moon, first quarter, June 3rd would be right here. We need the phase in between those, which would be the waxing crescent. 1. Just got to know your moon phases there. It gets light from the right. Number 9. Which graph most accurately represents the approximate percentage of the Earth's surface covered by the hydrosphere? Okay, so once you see something where you're like, how am I supposed to get these numbers? We're going to go on the reference table. So this one's going to be page 1. And we need the hydrosphere, and we need percentage of the Earth's surface covered in the hydrosphere. So actually, this is not going to help us. This is actually a rote question. So you have to know about 75% of the Earth is covered in water. So there you go. 3. Number 10. Which diagram shows the correct position of Polaris in the night sky as seen by an observer at Watertown, New York? So, okay, that's a city in New York. So I'm going to go to page 3 and find Watertown. And the altitude of Polaris here is equal to the observer's latitude. So all I need to do is find the latitude of New York. Polaris, first of all, is always in the north. So is there any not? It's definitely not going to be directly above the person's head. So that one's out. And this would be the equator. So that one's out. And I know Watertown is in New York, which is about 43 degrees north. So it's definitely not all the way up here. So I actually know this is the answer. But we could check to make sure Watertown's latitude is equal to this. So it should be about 43. Let's check it out. Go down to our page 3. And we look for Watertown, which is here. So yeah, it's about 44, and that checks out. So it's going to be 4. Number 11, which process transports groundwater upward through the soil? This is going to be, wrote again, capillary action. Or capillarity is the answer. It's when water moves up through you need very small particles to get that to work. Which cylinder contains the particles with the lowest porosity? Porosity is the space. So we need small particles, or we need unsorted. That's going to create the lowest amount of space. So this one's good, or the 3 millimeter particles. So the best one here is going to be the unsorted. That's going to have them, think about it like the most water get stuck in between them. So that's going to be 4. The small particles fill in the gaps of the big ones. So that's the best one. 13. Which factor is responsible for the circulation of convection currents occurring in the hydrosphere, troposphere, and mantle? Convection currents are due to density difference. That means warm things are rising and cold things are sinking. So it's going to be 3. We got arrows. Okay, so these are monsoons. So this is wind going from high to low pressure. It's bringing all the moisture from the water here and moving it onto the land. So in this, they're going to get tons of rain. And here, the air is high pressure here and low pressure here. So the air goes this way, the wind. So there's no water coming onto India. So this is a drought. So let's see. Compared to the amount of rainfall that India receives during the summer, the amount that they get during the winter, so they're going to have less because the wind is going from the land to the sea. So this is going to be 2. All right, we got a polar front jet stream, and it says it's during the winter. It brings extremely cold air from the far north to the United States. So essentially the wind's blowing this way. And then it comes down here, and then it zooms up back up here. So we get this cold air that's coming down from Canada. Oh, I just gave the answer. So the only thing that's different, so we got our arrows, which is here and here. So this one's wrong and this one's wrong. So is this CA up here or CT? This is tropical. So it's definitely not tropical in Canada. So this is going to be the answer here. Plus polar, think polar is cold. This is Arctic. The reason I knew the arrows were going down this way is because it follows the trade winds. So you got to go, you could check that out here. You could see in this area here, between 60 north and 30 north, all weather is pretty much going to go to the northeast over the United States. So we want the weather to generally go that way. So it's not going to go to the left. Which temperature zone is the polar front jet stream located? Oh, this was a repeat. So here's the polar front jet stream right here. The tropopause is here, so this X is right under the tropopause, so it's in the troposphere. So it's going to be 4. All right, we got a front question. Weather front symbol with its cross section. So cold front, this is an occluded front. There's 3 air masses. So that's wrong. This is a warm front. So we're just looking at the pictures first, and then we'll find the symbol second. This is an occluded front because there's 3. 1, 2, 3. And then this is a cold front because it's just cold air going this way with this big sort of slope here. So this is a occluded symbol. And by the way, how do you know the symbols? You go here, right there. No need to memorize them. This is a stationary front, so that's wrong. This is a cold front up here, so that's wrong. And this is a warm front, that checks out. 2. If the Tug Hill Plateau region of New York State is experiencing lake effect snow, winds are most likely blowing in which direction? Okay, so lake effect snow, essentially what we want, I'll just draw it down here. We want the wind to come over the lake and then drop all the water on the other side. That's the point of lake effect snow. It takes the water from the lake essentially and uses it to snow on the opposite side. So it's saying the Tug Hill Plateau region, so we got to go to the landscape regions map on here. Tug Hill Plateau here, and it's saying lake effect snow is there. Here's our Lake Ontario, so we need the air to go like this. So it's got to come from the northwest and go to the southeast, ideally. We'll see if that's a choice. West to east is probably the best answer there. 4. Which set of psychrometer measurements was recorded when the dew point was 4 degrees Celsius? Okay, and we have a dry bulb and a wet bulb. Okay, so let's see. This is an interesting question. I'm going to go to our dew point chart. Okay, so it's saying the dew point is 4, and they give you a dry bulb, wet bulb. So we got to get the differences here. So 4 minus 1 is 3. By the way, you do get a calculator on the region, so if you're not good at subtraction or you're worried about it, real quick, you could just plug it into your calculator and just, be absolutely sure. So 14 minus 9 is going to be 5. 20 minus 16 is 4. 28 minus 13 is 15. So now that we got our 4 subtracted things, we're going to go check those spots. So dry bulb 4, difference of 3. Dry bulb 4, 0, 1, 2, 3. Negative 4, is that the dew point? No. So this one's wrong. Dry bulb 14, difference of 5. Dry bulb 14, 0, 1, 2, 3, 4, 5. Yes, that one's good. Dry bulb 20, difference of 4. Dry bulb 20, 0, 1, 2, 3, 4. 14, that's wrong. And then dry bulb 28, difference of 15. Dry bulb 28, 15, negative 3. That's wrong. So this worked too. Compared to the summer and winter temperatures at low elevation, higher elevations have what? Okay, it's cold. It's cold on the top of mountains. So we definitely want colder winters. So that one's out and that one's out. And then same latitude, it's going to be just cold. So it's going to be 3. Cold, cold, cold. During which geologic period did humans first appear on Earth? So this is a reference table question. We're going to go here. We're going to go to our geologic timescale. Humans, right here. Quaternary time period. There we go. Easy. 22, radioactive decay of potassium 40. Okay, so we might need page 1 in the reference table. This is our radioactive decay chart right here. Potassium 40. We have disintegration into argon and calcium. We have a half-life of 1.3 times 10 to the 9th. Let's see. 1 billion year bedrock in Hudson Highlands, and it wants to know what percentage is left. So this is easy because you don't need to do anything besides see, okay, 1 million's like about there, and it's like maybe about here. If this is 13, here is like 6.5 million, just to give you an idea, is 75. So it's probably between 50 and 75. So I'm going to go with 60. That's how I would have did that. All right, next question. The surface bedrock at Old Forge, New York is mostly what? A lot of reference table questions on this. All right, we're going to go to Old Forge. It's here. It's these squiggly wiggly lines. And we're down here for that. Middle Proterozoic, nice quartzite marbles. All right, let's see if we could find that. Metamorphosed. Okay. And it's saying formed during the Grenville orogeny or formed during the Acadian orogeny. That's interesting. So let's see if there's info here. Middle Proterozoic. Wow, this question's annoying, right? So now we got to go to our time scale and we got to see Middle Proterozoic. Let's see. Proterozoics here. Middle Proterozoics here. That's like 1.5 billion. Alright, let's see what happens over there. Acadian orogeny, Grenville orogeny. Okay. So, this is how we're going to have to do this. My reference table is on 2 separate pages, but watch. Middle Proterozoics here. It's in this gray area, so we're going to go down, keep in the gray area. Right here, and then it would go to this page. Yours is going to be like the same right across. And look. Grenville orogeny. That question was hard. So it's going to be intensely metamorphosed rock during... That was tough. I would say this is tough. If you're getting something like that correct, you probably don't need to watch my video. Number 24. Which agent of erosion produced many of the large parallel grooves and scratches seen in the bedrock? Okay. Parallel grooves. Glaciers. They're striations. Boom. Easy. Number 25. The diagram below represents rock A changing into rock B. Okay. Rearrangement of atoms. Okay, so right when I see rearrangement of atoms, I automatically think metamorphism. Because that's like rearranging in like banding or foliation, something like that. So which process? So what we could do is we could find these rock symbols on our chart and probably get the answer. So even though we probably already know what it is. So this is dots and dashes. So that looks like this one. Siltstone turning into squiggly thingies. Squiggly thingies looks like schist. So siltstone to schist. Yeah, schist is metamorphic, so we were right. So that's going to be 4. 26. Which mineral is usually present in pegmatite, phyllite, and siltstone? Okay. I can't even get over this question 23, man. That was hard. Which mineral is usually present in pegmatite, phyllite, and siltstone? Okay. So let's see. We got to go here. Pegmatite here. Phyllite. Did it say phyllite? No, it didn't. Yeah, phyllite and siltstone. So pegmatite, these 1, 2, 3, 4, 5. Potassium, feldspar, quartz, plagioclase, biotite, amphibole. Okay. Phyllite is here, so that's going to have garnet, amphibole, feldspar, quartz, and mica. So our so far we have quartz or amphibole. Quartz or amphibole, that have in common. So now siltstone is just quartz, feldspar, and other clay materials. So quartz. I think that's the only one that has all 3. Oops, I'm on the wrong question there. Quartz. Perfect. Hardness, great. We got hardness items. Which mineral could be scratched by an iron nail but not a penny coin? Okay, this is how I would do this. I would go to the mineral chart. All the way down here. And we're going to find these separately. So I'm going to go quartz. Whoops. Quartz, 7. I'm going to go like this. 7. Dolomite, 3.5. Amphibole. So like this is kind of time consuming one. You might take a minute for this. 5.5. Halite, 2.5. Okay, so now that I got my numbers here, now I don't need the chart anymore. So which mineral could be scratched by an iron nail? So it could be scratched by an iron nail. So that's out, 4.5, and that's out. So now we're between here. But not by a penny. 3. Dolomite can't be scratched by a penny. So halite could. So this is out, so it's 3. That's how I would tackle that. Which graph shows the relationship between an increase in urbanization? Okay, this means that the area is becoming a city. So what does that entail? That would entail roads, like pavements, lots of people, less trees, things like that. And the average annual air temperature. Okay, so they're going for air temperature. So they're going to have like cities, right? So that's going to be like more smoke and pollution. So temperature is going to go up right there automatically. So it's going to be 1. All right, 29. Which events occurred after the formation of rock layer A? Okay, so rock layer is here and here. So it seems like this fault happened after A because they're split, right? So this is all split. So the fault is definitely after A. And then this intrusion here also cut through A. So it would be the intrusion and the fault. 1. And then you could also say this, but that's not a choice. All right, we got a mid-ocean ridge. Okay, so automatically, this is divergent plate boundary. This is a magnetic field lines. And the magnetic field lines correspond to be the same. So like that one's that one, this one's this one, so on and so forth. Which 2 locations on the each side represent areas of reverse magnetic polarity? So the dark. Okay, so let's get rid of all my lines here. Okay, so ready? I'm just going to say this area is dark, which means this area is dark. This area is light. This area is dark. This area is light. This area is dark. I got my answer. It's B and D. Little white sliver. Here, I'm here. I'm over here. That's white. That means this is dark. That's light. This is dark. So it looks like B and D. 2. It's a mirror image. This is your mirror right there. All right, 31. Which feature will form a kettle lake? That's a glacier. It's a giant buried ice block. That right there is going to make a hole and then melt, so it's B. This is like the definition of a kettle lake. All right, we got a P wave, S wave. Seismic station located 2,000 kilometers away. Which seismogram indicates the correct time difference between the arrival of the first P wave and the first S wave? Okay, 2,000 kilometers. So let's see what we got here. I'm going to go to our thingy. 2,000 kilometers. So it's like here, 4 minutes about, and then 7:20. So let's see. P wave about 4 minutes, 7, and then 7:20. So that's going to be like it's about a 3 minute and 20-second difference. Can that help us anywhere? So this looks like 20 seconds each. So this is 2 minutes and 20 seconds. This is 4 minutes here. So that's 4 minutes. 2 minutes, 20 seconds. Let's see, is this P wave 0, 5 minutes? Please be 3 minutes and 20 seconds. Yay! That was it. Alright, 33, we got a topographic map. Oh, we got a river. Okay, the river flows this way because the contour lines bend upstream. So I want to know where it's the fastest, where the contour lines are close together. This is going to be the steepest area, so it's going to be like a cliff, essentially. It's going to be like a waterfall area, maybe, rapids and stuff. So B and C is going to be the best, too. Which chart best summarizes the landscape regions of climate A and B? Okay, I'm not even looking at the choices here. Rolling hills on the left. This is humid. This is dry or arid. This would be like forest. This would be like desert. These are flat. This is like a plateau. And rolling hills over here can also be plateaus. So these are actually both going to be plateaus. Mountains would be like you see like giant peaks and stuff like that, which this is not. So we got two plateaus, and then this one would be humid because it's rolling hills, and this is dry because it's angular. So this one. All right, 35. We got coastlines, wave action. So these are barrier islands. I don't even know what the question is going to ask, but those are barrier islands. They essentially protect the mainland from erosion. So like from like maybe like a hurricane or something like that. So that's like beach erosion stuff. So, all right, well, there you go. All right, 36, right? Yeah. All right, so we got a little reading. Hurricane Sandy was one of the most severe hurricanes in the northeastern United States. There, made landfall in New Jersey, 14-foot storm surge, rise in level of ocean water. Okay, strong winds, low air pressure, great. The moon enhanced this because it was in full moon phase. During a full moon, the above normal high tides, okay, which is a spring tide, by the way. So that's spring tides. Spring tides. Okay, which wind circulation pattern? Okay, so this is a low pressure. So this is going to be lick. Low inwards counterclockwise. That's how you remember that. So counterclockwise and inward too. Which air temperature and moisture characteristics are the source region over which Hurricane Sandy formed? Where did it form? In the reading. Did it say? Okay, so it didn't say, which means they need to, essentially you need to know that hurricanes need warm ocean water. So they didn't say like Gulf of Mexico or anything like that, so this is going to be 4. Obviously, hurricane's full of water, so don't pick dry. Alright, we got a solar system. So we got the terrestrial planets, the Jovian planets, and this is heliocentric, right, because the sun's in the middle. And Mars and Jupiter here, there's no asteroid belt in between them in the picture. We'll see. In our solar system, the planets are best described as, so it's elliptical, and the sun as it one in the foci. This is Kepler's laws right there. So we don't travel in perfect circles. Even though this picture looks like perfect circles, they can't be. They're not allowed to be. Which planet takes approximately twice as long as Earth to complete one revolution? So one revolution for Earth is 1 year, so we need 2 years for a revolution. So it's going to be somewhere further out, most likely, because remember, the further away you are, the longer it takes to revolve. We're going to go to our little solar system chart, go to period of revolution, 365 days, look, double that, Mars. Alright, we got our longitudinal lines here. So these are time zones. I'm just writing things that I know here. Longitude. As you go east, time will increase. As you go west, time will get less by 1 hour every 15 degrees. And that's probably what this is going to be about. Which line passes through New York State? Okay, so to do that, you could go here. That was surprising, actually, this question. Okay, here's New York State. Look, 73, 74, 75, 76, 77, 78, 79. So we're looking for 73 to 79. West. Yes. What is the time at 3 o'clock? Wow. What is the time at 30 west when it is 7 a.m. at 30 east? Okay, let's see. It's 7 a.m. at 30 east. So I don't want to use that chart, so I'm just going to go like this. 7 a.m. at 30 east. And I need to know what is it at 30 west. Okay, so here's 15 east. Here's 0. Here's 15 west. Here's 30 west. So what is it there? 7, 6, 5, 4, 3 a.m. 3. 42. Which geologic principle can be used to support the inference that rock layers A through D experienced crustal movement? They're tilted. They're not supposed to be tilted. They're supposed to be originally horizontal. So this is going to be 1. Original horizontality, meaning that everything is essentially deposited in horizontal layers first, and then if it was tilted like this on an angle, right, that shouldn't be like that. During the Ordovician period, when layer C was forming, what's layer C? Okay, that's shale with this index fossil in it. The United States were inferred to be located where? Okay, so we're going to go here. Time scale. Ordovician period is going to be, oh, it's going to be hard for me. Here, so it's like 2 boxes above the gray. So gray, 1, 2, that's here. So here, North America is on the equator. Slightly north of the equator. The United States, let's see, United States, it's actually slightly south of the equator. Is that a, yeah, 2. By the way, if there's any particular topic, as I'm going through this, that you are confused on, go check out my playlist where there's 33 individual videos that go over every topic specifically. This is more like a general overview. I'm assuming you have basic knowledge to be able to follow along with me on this. So if you're completely lost, you have to go back and watch the videos, the specific videos on the things that you're like most confused on. 44. The geologic feature represented by letter F is most likely a... Where's letter F? Oh, here. Okay, this squiggly line, that means that there was a layer there, but it was eroded away. So we call that a buried erosional surface, and its nickname is an unconformity. Oh, great. So 1. It'll say either one of those. Carbon-14 was not used to date trilobite fossils because the trilobites... Yeah, so this is for, like, recent things. So recently living, maybe, like, people, mammoth fossils, things like that. Trilobites are way too old to be using carbon-14. Which water cycle process releases 2,260 joules of energy per gram? Okay. Which water cycle process releases 2,260? Let's see. So we're going to go here. Release 2,260. We need condensation. So condensation makes a cloud, so it's going to be D. I'll just tell you what these are real quick. This is evaporation. This is runoff. This is transpiration. This is precipitation. C is more runoff. F is infiltration. Which one would most likely represent the height of the water table if E and F increase? So E and F, E is precipitation and F is infiltration. So more water is coming down into the ground. So water table is going to go up. So it's going to be this one. Water table is like pooling of water underneath the ground. So it's going to be more of it too. This one shows about the same, this one shows less, and this one shows way less in that area. Which location receiving direct rays from the sun? Okay, North Pole's tilted away from the sun, which means we're getting winter, they're getting summer. So 23.5 degrees south is getting the direct ray. This is December 21st, so it's going to be C. (49) Equal areas of what type of land usually absorb the most insolation? Okay, absorb, dark, and rough. It's just memorize. 4. Most of the energy radiated by these land surfaces into space in the form... Okay, going from space, so if this is the ground and you're going... The heat's going out into space, this is infrared. It's heat. The Earth gives off heat. If these three things were coming out of the ground, first of all, you would see light coming out of the ground. This would be really bad. This would give you, like, skin cancer, and gamma rays would just kill us eventually. So heat comes out of the ground. All right, that was the multiple choice. All right, let's go. Part 2. Here we go. 35 more questions. We got a crushed stone in New York State. Crushed stone is any bedrock that has been broken into smaller, irregularly shaped fragments. Okay, they can range from silt to boulders. Smallest size could be used to make concrete and cement. Larger size could be used to line a riverbank to prevent stream erosion. Okay. Crushed stone is used in agriculture. Most is used in the building and construction industry. Shale is found in New York State. Rarely mined because it's tend to weather too easily. Okay. We got percentage of how much of this stuff is mined. Wonderful. Explain why shale is rarely used in the building and construction industry. Well, it says it. Shale is rarely mined because it tend to weather too easily. So that is a free question. Weathers too easily. Okay, that was great. We like that. All right, 52. In the building and construction industry, rock sold as granite might actually be gneiss. Identify one observable property of gneiss that could use to distinguish from granite. Okay, so we need to say something about gneiss that isn't granite. Okay, so let's go here. We'll go down. Now, you might just know this off the top of your head, but we're just going to show you. Granite here is intrusive igneous rock, has coarse grains. Thing about gneiss, banding. Banding or foliation are going to be your answers there. I'm going to write banding. You could also write foliation. 53. Identify one mineral found in the sandstone that's used to make glass. Who's my Minecraft people? We should know this. Let's see. Sandstone. So we'll go to sandstone. Quartz, feldspar, and clay. So quartz, feldspar, or clay. Go down here. Quartz, made from glass. It's quartz. $54. Okay, what do we got going on here? Predicted distance of stars relative to the sun over time. Okay, we got time scale on the bottom, and then distance from the sun in light years over here. And we got different star names and different lines. Okay, determine the approximate present-day distance in light years from the sun to this thing. Lalande, 21185. Okay, Lalande. Let's see, Lalande, 21185. Look, present, right here, stay on the line. It's going to be right here. So like 8.6 light years away. That'll be like that. Is that good? Lalande. 55. Identify the star that will show a redshift in wavelength from 15,000 years from the present. Okay, so first of all, redshift means it's going away. So we need it to be going away from us. So 15,000 years to the present. So here's 15,000 years to the present. And we need the star to be going away from us over that time. So which means it needs to be getting further away. So over time, it seems like Bernard's star right here at this point is starting to go further away. Up is away in this case, because that would be distance increasing. So Bernard's star is the answer there. That was hard. So I would say this question So far, in my opinion, there's been two hard questions. That one and the other one that I said before. 56. Relative luminosity of Alpha Centauri. Oh, I'm not even reading a question right now. Proxima Centauri is the closest star to Earth. Alpha Centauri is more easily visible. In your answer booklet, circle the relative luminosity and mass of Alpha Centauri compared with Proxima Centauri. Okay. I'm going to go here. So Alpha Centauri is here, and we're comparing that to Proxima Centauri here. So Alpha Centauri is more massive, higher up. It's also hotter. Is that what it wants? More mass, hotter, it'll also be greater luminosity. Luminosity is directly related to mass. More mass, more bright. So there you go for 56. Okay. 57. State the name of the galaxy which all these are located. Okay, it's our galaxy. Right? You don't need to know any galaxies, memorize, except ours. Yeah, look. There it is. That's what I was looking for. Our galaxy. So, Milky Way. Which makes me want a Milky Way. Even though it's 9 o'clock in the morning. Okay, 58. Identify the nuclear process that produces most energy released from stars. Okay, you only have to memorize one nuclear process. Nuclear fusion is inside stars. That's the only one you ever write. Don't write fission. We don't learn that. 59. Okay, we got a weather station. We like these. In your table, identify the numerical value of data on the station model measured by each weather instrument given. Include units. Okay, what? What? Oh, okay. And wow, this one's kind of hard. So you need to know here, an anemometer measures wind speed. It's like a two-part question because you got to know what these are. And this is obviously going to measure rain amount. And then you need to go to those spots on the weather station. So we're going to go here, weather station. So we need to get the wind speed and the precipitation. So precipitation's easy. It's going to be in the bottom right, 0.31. And it wants units. So let's check the unit on the reference table. Look, inches. Anemometer, wind speed. That's going to be the flags here. So it looks like 10, 20, and then the unit is knots. My advice is spell out all the units. If they do that to you, don't make fake abbreviations. I would just spell them out like I did. Because some people will just write I, because they think I is inches, but it's IN, and you get the whole question wrong. So just spell them out. Based on the data, explain how a scientist could infer that there was high relative humidity. Okay. High relative humidity, you want the temperature close to the dew point. You could also say lots of clouds. Or you could say, actually, that's kind of not scientific. I would say 100% cloud coverage. I mean, honestly, if you wrote lots of clouds, I'd probably take it. But I didn't tell you that. So we'll say temperature is close to the dew point. You could also probably say it's raining. There's precipitation. There's a lot of answers for that one. Okay. 61. Oh, I hope we get to draw an iso line. I like iso lines. Oh man, a reading. Woohoo! Okay, let's see. Alaskan rebound. The fastest measured rate of uplift on Earth today are in Southeast Alaska. Scientists first hypothesized the causes of tectonic forces. Okay, great. Since the region is located on the plate boundary where mountain building occurred. Scientists now hypothesize another factor. Blah, blah, blah. During the last ice age, the weight of the mountain glaciers caused the lithosphere to sink lower into the plastic mantle. As atmospheric greenhouse gases increased the climate change, causing glaciers to melt. Loss of the weight made the crust rebound and float higher, increasing elevation. It's called glacial rebound. It accounts for the continental uplift rates and the rebound maps on your answer sheet. Okay. We got this. Okay, so, you know, based on this already, I probably know that I'm going to have to go here. So guess. We're here. This is where that picture is, up there. Okay, let's see what's going on here. Draw the 8 millimeter per year and 12 millimeter per year isolines. Okay. Gladly. 8 and 12. Okay, ready? 8, edge of the page. 8, 8. Between 6 and 12 to get that 8. Between 10 and 6 to get that 8. Get this one. Between 6 to get that one. There's another 8 here. Whoa, that part got real squiggly. I don't like that. It's really hard to draw on my computer. So it says here, this is where I kind of get weird about this. Oh, extend to the edge of the map or the edge of the land area. So you can stop there because it's only in the land, or you can technically go like this. But I think that looks cleaner, so we'll stick with that. All right, we gotta draw 12. 12, here we go, 12. 12, 12, 12. Here, here, here. Whoa, we gotta squeeze here. Ready, go. 12, there. Again, you could do this. I'm not doing that. I'll just leave it at the end of the land because I like it. Alright, great. The greatest rate of uplift occurred around location A. State one possible value in millimeters per year for location A. Where's A? Here. Okay, so here's 24, 28. So 32 would be the next line. So this could be 29, 30, or 31 because they're going up by 4s. I'll put 30 because it's nicer. You could put any of them, though. Identify the name of the plastic mantle layer in which the lithosphere sank. That was easy. Go down here. Look, plastic mantle. Asthenosphere. Okay, 64. Still with me? Hope so. Identify the names of 2 tectonic plates that are on either side of the plate boundaries that are shown within the map. Okay, we called it. So this one here and this one here. Oh, I lost my page. So this one here is the North American plate, and this one here is the Pacific plate. Look, North American plate's this, Pacific plate's that. That's the answers. As you do a lot of these, they're just predictable. Alright, 65. Identify 2 major greenhouse gases that contribute to the melting. Okay, there's 3 you gotta know. Carbon dioxide is a greenhouse gas. Water vapor is a greenhouse gas. Methane is a greenhouse gas. And then chlorofluorocarbons, but no one ever really remembers that. So I would just stick with the top 3. CO2, water vapor, methane. Alright, 66. Cruising. On the diagram in your answer booklet, draw the path for November 5th. Okay. Alright, let's see. So this is Binghamton, New York. So path A, this is going to be... Okay, first of all, path B here, this is the equinox. So this is going to be 321 or 923. This is going to be the summer here, or a summery day. Oh, it does say the first day of each season. Okay, fine. So this is June. This is December. Alright, so November is between September and December, so it's going to be in this zone. So I'm just going to go like this. Whee! Great. Done. Do I have to label it or anything? Sun's past... No, good. Describe how the length of the shadow changes from sunrise to sunset as it appears to travel along path A. Okay, so I'm just going to draw here. When the sun is low, the shadows... Oh, I don't like my picture already. When the sun's low, the shadow's long. When the sun's high up, the shadow's shorter. And then when it's setting, over here, again, the shadow's long. So it's going to go long, short, long. Or you could say like decreases and then increases, I would say. Shadow decreases, then increases. Man, this question here, I'm looking ahead. We've seen one like this on so many times now. It's like getting old. Okay, 68. Identify the time of day indicated by the sun's position on path B. Use AM or PM in your response. Here's path B. Okay, so if this is the equinox, you have to know how to assume this. This is 6 a.m. This spot here is 6 p.m. This is 12 p.m. right at the top, because it's a 12-hour day. So this is probably 9 a.m. I mean, 9 or 10. Say probably. I would put 9. 9 a.m. Okay. Next question. Circle the relative intensity of insolation and duration of insolation of the sun for path C compared to path B. So let's see. Path C is going to be a lower duration and lower insolation because it's wintertime, so it's colder and shorter days. So less intense sun, shorter duration. Alright, 70. Identify the time period of the bedrock in which this fossil can be found. Okay. We need to find that. So to do that, go down here. Find it. We don't see it. Oh no. Oh yeah, we do. Boom, right? Is that the one? Yeah. Alright, great. So what time period is that found? Let's see. M. So again, my reference table will be hard to see this. Look, M is here. So you have to go across. So this is going to be 1, 2, 3 above the bold line. 1, 2, 3 above the bold line. So you would be coming over here. Silurian is the answer here. Okay, 71. Describe one characteristic necessary for this fossil to be classified as an index fossil. Index fossils need a large geographic area or exist for a short time period. That you just have to remember. 72. Infer the past environment that existed at a New York State location where Eurypterid fossils have been discovered in the bedrock. So, Eurypterid, it says it's a group of extinct marine animals. So this has to be some type of water environment. So I would say, you could probably just say marine environment, obviously. So that came out of the reading on the top. But I could see how you might get stumped on that. I wouldn't say that's a hard question, though. So I say still 2 hard questions on this. 73. Here we go. In your answer book, circle felsic or mafic to indicate the composition of the rock at Federal Plaza and list 2 minerals found in this rock. Okay, let's see. Federal Plaza. Federal Plaza. These buildings contain granite from Avalon, a small continent that was once attached to the east coast when Africa. Okay, granite. So we need to say felsic or mafic and then 2 minerals in granite. Alright, go to granite. Page 6, granite. Okay, look. Left side, felsic. Could write that. Minerals in granite. There's 5. 1, 2, 3, 4, 5. So quartz and biotite. I'm picking. You know why? Because they're the shortest to write. But you could write, you know, any of the other ones. Potassium feldspar, amphibole, biotite. Those are good. Identify the landscape region where the bedrock most likely contains the same coral fossils as the one found in Morocco. Okay. So, some building contains stone that comes from Morocco in North Africa that contains... Okay, this is what we need. 370 million year old coral fossils. Okay. And any other hints here? Alright, well, let's go check if we see anything here. 370 million years ago would be here. Wow. So it's Devonian. This is hard. Okay, so we need Devonian. We need a Devonian bedrock on page 3. This is the 3rd hard question. So then we would go here. Dots. Here's the dots. So this area here. right? And then they want a landscape region. Oh my gosh! So it's this. This is the hardest question on the test. Allegheny Plateau. That is the hardest question on the test. Those cruel, cruel, cruel people. Wow. Wow. That was ridiculous. Okay. 25. Explain how the 15,000-foot mountain was reduced to small hills in today's Central Park. So let's see. The exposed bedrock is schist, what remains of ancient mountains. The mountain formed from ocean bottom mud that was heated. Okay. So if that's gone, it was eroded. It was weathered and eroded. That's really the only thing that you can get out of that. Okay. 10 more. Alright, we got a plate tectonics map. Okay. Nothing in the top here. I always scan this just to see if there's anything that is useful. Crustal plate movement. Okay. 2 letters that indicate the location of transform boundaries. So for transform boundaries, we're looking for this. So the arrows going opposite or that solid line in between. So it looks like we're going to have this spot here and this spot here. F and B. Okay. Explain why earthquakes are most likely to occur at location H, then A. H is on a divergent plate boundary, and A is not. A is not on a plate boundary. H is on a plate boundary. That's all I need to say. Alright, 78. Scientists infer that the magma that formed the hotspot over E originates at the boundary between the stiffer mantle and the outer core. Determine the depth where that would be. Okay, so this is going to be page 10. Stiffer mantle, outer core right here. Go all the way down, follow this down. The depth is right there, 2,900 kilometers about. Okay, state the name and density of the igneous rock found at the surface of the oceanic Pacific crust. Okay, look right here. Basaltic. It's basalt. And the density is right there, 3.0. So, basalt. .0. By the way, make sure you write neat on the regents because mine right there looks like 3.6, which is not good. We want 3.0. Alright, we're on question 80. On the map, draw an X along the stream bank where there's more erosion than deposition. Okay. Here. On the outside of the curve, because that's where it's going to be fastest. So there's going to be more erosion at that spot there. Alright, 81. The velocity of the stream was determined to be greater at location B than location A. State one possible reason why the stream velocity would be greater at location B. Well, there could be a bunch of reasons. Probably the fact that the first one that comes to mind is that it's steeper. So B could be like on a hill. That would probably be a good answer. So I would say probably steeper. Steeper slope. Okay. We're going to go 82. Describe one change that would occur to an angular pebble as it's transported by the stream for a long amount of time. So that's going to be abrasion, and essentially the angles are going to chip off. So if you have an angular fragment, the edges would chip off and it would round it out. So it would become rounded. You could also say it gets smaller. You could also say it gets smoother. Any of those they'd probably take. Alright, 83. We got some type of air temperature map here. On the graph, construct a line graph by plotting the monthly average high temperature for the month listed data. Oh my gosh. We gotta do all of these? For real? I'll plot one just so you could see. Okay. So we want La Junta, Argentina, right here. So January would be 29. So you go here, January, and then 29. You put a dot there. Okay, and then you just go across. Not going to do all those. 84. State one reason that Chile has a smaller yearly temperature range than La Junta, Argentina. Okay, so check this out. This place is inland. This place is on the coast. So areas on the coast have smaller temperature range. It's on the coast. That means that the water has such a high specific heat that it doesn't allow the areas to get too hot or too cold. Explain why both of these places have their coolest air temperatures in the year June, July, and they're warm in December, January, February. It's because they're in the southern hemisphere. Southern hemisphere gets opposite seasons than us. Alright, there we go. All 85 questions done. Hopefully you guys stuck with me. If you like these types of videos, I will keep cranking out Regencies for you as much as you want. Good luck studying, and I'll catch you on the next one. Bye.